Okay, because of the complex nature of adding and subtracting vectors, I wanted to make sure that we went and did a second example. So here's another example for anyone interested. Now, we're going to have b minus a, so we're going to start with this one down here, then we're going to be shooting this one up because it's going to be the opposite of a. So let's put this one over here. 5 centimeters at 200 degrees. Then we take A, put the tail of this one here at the head of this one, and normally it would go off in this direction, but because it's negative A, it's going to flip and go back in that direction. Now, what would have been 330 leaving 30 degrees here means that because of vertical angles, the 30 degrees is now up in here. So, what we need to do is find a resultant. That resultant is going to be from the tail of the first to the head of the last. That's what we're looking for. Now, I know 5. I know 11. What I need is I need this angle in here. Now, if this is 200, that means from the axis down is going to be 20 degrees, which means opposite angles. So if I have alternate interior angles, if this is 20, this is 20. So I have 180, take out 20, take out 30, leaves 130 degrees. So I now have enough information to use side angle side and say the resultant squared equals 11 squared plus 5 squared minus 2 times 11 times 5 cosine 130. Now, I'm going to go ahead and plug this in. My camera froze, but by finished plugging in the formula, you get this. I'm going to pause, put it into the calculator. Okay, so we've put it into the calculator. We hit enter, but again, remember that r squared equals 216.7 ... So we hit second, square root, second answer, enter. We come up with r equals 14.7. Now, if I look at this, I have 5 and I have 11. That's a total of 16, but I have a nice big angle, so 14.7 does make quite a bit of sense. Now what we're going to need to do is that now that we have the length or magnitude, we're going to need to find the direction. To do that, I need to find this angle in here. So I'm going to set up a law of sines, and I can say sine of x, which is what I'm looking for, is across from 11, as sine of 130 is across from 14.7. I'll plug it in and be back in a moment. Okay, using the law of sines, we come up with 0.374, etc. But again, don't forget that that's going to be the sine of x equals 0.374, meaning we need to take the inverse sine of both sides. So second, inverse sine, second, answer, enter. We get basically 22 degrees. Now, if I have 22 degrees inside, let's take this and blow it up right out here. We have the axis, we have a vector going this way, and our resultant takes off this way. The resultant's angle is 22. We know that from the 200, we have 180 leaving 20 extra beyond. So this part right here is the difference between the 22 and the 20. That means 2 degrees shy of that. 2 degrees shy of 180, so 180 minus 2 is 178. So we have 14.7 at 178 degrees. For all of you kiddos that love to have one way that everything works, you're going to hate vectors because every picture is different, every situation is different, and you have to examine what do I have, what do I need, what can I find. It's significantly more complex, but you can do it.